Hi everyone, welcome to Lab3 One-Sample z-test. Before our lab, I want to say if you have any question, please send to this email address xgu2@pridehofstra.edu. Because today I checked my old email address, this one, xixi.gu@hofstra.edu. I found a lot of your emails because I didn't use this email address a lot, so I didn't give you quick response. If you have any further questions, please send to the right email address xgu2@pridehofstra.edu. So here is Lab3 exercise. Question 2 and 1, you need to state noun and research hypothesis, and then determine if it is a one-tailed or two-tailed test. So because 1 and 2 were very similar, I will talk about 1 and you will do question 2 by yourself. 3 and 4 question is about conducting simple z-test. I will explain how to conduct one simple z-test for question 3, and you can do question 4 by yourself. And then question 5, you need to use R to run one simple z-test. So I will show you how to do that step by step. Let's look at our first question. So from the last sentence, we know the income of mall shoppers is higher than that of general population. It gives us the directions for this hypothesis. So this should be one-tailed hypothesis. And for the non-hypothesis, you can see like this. Mu represents the general population mean, and 52,500 represent the mean household income of small shoppers. Our alternative hypothesis is the mu higher than the mean household income of small shoppers. So we want to support the alternative hypothesis and reject the non-hypothesis. So this is the whole answer for question 1. For question 3, so firstly we need to write down the non-hypothesis and the alternative hypothesis. The non-hypothesis should say there is no difference, and the alternative hypothesis should be there is differences. This is a two-tailed test because it didn't tell us which one is bigger than the other, like this. Because this is a two-tailed test, so in each tail, the alpha value should be 0.025. To get the z-score, we need to check the z-table. We need to find the value 0.025, which is here. Then we can get the critical z-score. Start with 1.9, and the second decimal is, so we follow this line, the second decimal is 6. So the final critical z value is positive and negative 1.96. So we can draw a graph like this. We get two critical z-score. The first critical z-score is negative and the other is positive 1.96. If the observation z-score exists in this area, we cannot reject the non-hypothesis. But if the observed z in the red area, no matter in this side or the other side, we could reject the non-hypothesis. So now we need to calculate the observed z. Through the first equation, we already knew the mu is 15 and the sample size n is 20. We can calculate the sigma standard deviation of population, which is 3.36, and then we can use the other equation to calculate the observed z-score. Use a simple mean 97.3 minus 100, then we can get negative 0.8. Because the observed z-score did not exist the critical value in the negative tail, so we fail to reject the null hypothesis. The observed score is in this area, so we fail to reject the null hypothesis. So let's look at the last question. We need to use R to conduct one sample z-test. Firstly, we need to state the hypothesis. Null hypothesis should be there is no difference between scientist score and the population. The alternative hypothesis should be the mean is different, like this. Because this is a two-tailed test, the alpha at each tail should be 0.025, and the z-critic should be positive and negative 1.69. Now we need to use R to calculate the observed z-value, then compare the observed z-value with critic z. So firstly, you need to build a variable and name this variable as b, and then enter our sample scores from 21 to 19. It is here, from 21 to 19. And then I build the z observed equation by myself, like use the mean of our sample minus mu, which is 22, and then divide the standard deviation of our sample, like this part. Enter the observed to get the final score. Select it and then click Run. So from the console window, you can see I get the observed score, which is 1.06066. So you can make a summary like this. Because the observed z-value 1.06 is smaller than the positive critic z-value 1.96, we fail to reject null hypothesis. That's all about the final question.